Harvard scientist David Sinclair has spent the last 20 years working to defy aging.
How many times have you heard, if you're over the age of 40, well, you're getting sick, you're getting this pain, your eyesight's degrading. Don't worry, that's just normal aging. I really don't agree with that approach.
Sinclair believes the root cause of aging and health decline stems from damage to the so-called epigenome, the part of our cells that turn genes on or off.
Our bodies have two different types of information. We all know about the DNA. Now, there's another type of information that most people don't know about. It's called the epigenome, and it's the reader of the DNA. Like, if you have a compact disc, it's like scratches on the compact disc, so you can't read the music. As we get older, we lose the ability to read our DNA correctly.
And so how do we get those scratches off?
We had this breakthrough a couple of years ago, and so we found that there was a way to get the scratches off and reverse the age of cells.
In his study, Sinclair restored optic nerve cells and sight in mice with vision loss from both aging and a condition that stimulated glaucoma.
The way we did that in the mice, and we cured blindness with them, was to turn on 3 genes that are normally on in embryos. And when we turn those 3 genes back on in the adult tissue, the mice regenerate and they get their vision back.
And now, in what the researchers are calling the first study of its kind, Sinclair and his team were able to age the mice and then make them younger again. In this video shared by Harvard, these mice are the same age, yet one is visibly older. How did they do it? By literally breaking up the DNA, forcing the body to repair itself, which he says accelerates aging.
The mice actually do not just look old, but they literally are older by about 50%. They get gray hair, they get wrinkled skin, their organs are old.
The results were shared at a conference earlier this year and are under review for publication. This groundbreaking technology builds on the Nobel Prize-winning work of Japanese scientist Shinya Yamanaka, who discovered how cells can be reprogrammed to be stem cells, which then can develop into cells of any type in the body. Using this method, Sinclair showed me how his team is trying to study memory loss by turning skin cells into tiny brains.
Here they are, these little beauties. So these are mini human brains we've grown for a number of months, and these ones have been aged so that they're 70 years old, and we can measure their activity, and their brain activity is slowing down as they get older. They're full of inflammation like a normal old brain would be, and in this experiment we're now testing, can we reverse the age of those brains so they work again? And the answer is yeah, we can do that.
In early experiments, his team says they are using electrodes to measure activity in cells from the brain.
As those get older, they fire less, and then we can reverse that and get them to work again.
And so you've seen that by reversing it, they start firing more.
That's right. Yep, we can make them young again and work like they used to.
While much more research is needed, Sinclair hopes that one day, reversing aging could be as simple as a pill at the doctor's office.
So maybe once a year you go get a prescription for your doctor, you take it for a week, and it reverses your aging? Is that your vision here?
Well, it's not just a vision, it's going to happen. It's like asking the Wright brothers, are we going to fly? Well, of course we are. It's just a question of when.
Dr. Akshay Syal joins us now. I have seen Resident Evil too many times. So, of course, I'm wondering, you want to edit my genes, even for anti-aging? What? This sounds like it's both really tough science and potentially quite risky. Like, what's the flip side of all this?
Well, so, the qualifier here is there's a lot more work that needs to be done. But to your point, I mean, it sounds like science fiction. I mean, he's taking these mice who couldn't see from getting older, from getting glaucoma, which is damage to the optic nerve, and he's restoring their vision. I mean, it does sound a little bit like science fiction, to your point.
What is the timeline, though, for making this a reality? I mean, for something like a drug, like there's a whole process, phase 1, 2, 3 trials, but what does the doctor say the timeline is for this?
Yeah, so, he's hopeful in the next 10 to 15 years, but the thing is, you do need more rigorous studies in animals. You really need to prove that this works. And then after that, you need to trial this in humans. You need to prove it's not only, working as it should, but it's also safe, and it doesn't cause any unwanted side effects. Like you just talked about, you're editing your genes. I mean, that's probably going to be a big concern for a lot of people.
Although, on the flip side, just so the sci-fi nerds among me don't have the last word, we have come a long way in terms of what we can do with genetic editing, with procedures like CRISPR and so on, really being able to manipulate genetic codes in fairly stable and replicable ways, right?
Yeah, and so, Dr. Sinclair has been studying this for the last 20 years. He started out at MIT, and he's had this lab at Harvard for decades now. And, what he's basically saying is that if you'd asked him 20 years ago, would I be here today? Would I have restored vision in mice? I think he'd tell you he was pretty surprised. He didn't think we'd come this far so quickly. So, yes, it does sound like science fiction, but it's really, really promising at this point.
How does this compare to some of the other science that's going on in terms of anti-aging? Actual laboratory bench science, not like the infomercials we see at 2 a.m. Where else does the research lie?
You know, I think you and I could do a whole show on, the creams that are available and the potions they sell over the counter about, take this and you reduce your aging.
Pills and potions and lotions and everything and anything. But setting all that aside, where's the science?
No, we'll leave that to Professor Snape. This is,
exactly.
This is it's a Harvard-funded lab. These are people who are actually going in and altering your DNA in a way that, they develop these biological clocks. And these are, to be fair, things that need to be validated still. But they've come out with a way that they think is you're able to tell somebody's age just by looking at a DNA sequence. So, when you compare that to these creams and these things that you're selling over the counter, it's a separate world.
And are there other applications for this kind of epigenetic technology other than anti-aging? This isn't new technology, as you mentioned. This is just a new application.
So it's been a theory for a long time, and we're still working to prove that theory. But it is something that Sinclair has coined called the information theory of aging, where you take these epigenetic changes and that accelerates aging, as we've seen in the mice that's coming out. But to answer your question, the uses outside of this, it's still so new that we really don't know yet.
I know that he mentioned kind of like popping a pill, but is that what we expect it would be, like a pill, or more like a treatment like dialysis or something long term? Like what would the delivery device potentially be?
Yeah, so the delivery device so far in the mice has been, it's actually an injection. It's a harmless virus encoded with 3 reprogramming genes. And you take that injection, and then you take an antibiotic called doxycycline. So it's an antibiotic that you would give by mouth that turns on those genes and allows the anti-aging process to commence. So we don't really know what the future is going to look like, but that's what they've done so far in the animals.
Now, you already said a virus, and I know that immediately made some people's ears perk up, but this is just kind of a genetic vessel, basically, because a virus is just kind of a bundle of genetic material, right?
Yeah, it's a harmless version of what's an adenovirus. It's commonly used in science. It has other applications as well, but, I don't want people.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.